industrial consumers of electricity. We represent these large industrials before the Federal Energy Regulatory Commission, Congress, other federal agencies, and we are the only trade association for large end users that have representation before the North American Reliability Corporation. So with that, I'm going to go ahead and introduce our speakers for this afternoon. So first up, we have RP Covarrubia. He is the Chief Executive Officer, Chairman of the Board, and founder of CE. He started his career with Universe Capital Partners as an equities analyst. This firm was a 250 million AUM fund. He was quickly promoted to VP of Investments and left Universe in 2014 to create his real estate venture capital firm, CC2, focused on hold on, I think we have background noise. I'm just going to have to mute. Apologize for that. Okay, apologies for that. We had a little bit of background noise. So RP was promoted to VP of Investments and left Universe in 2014 to create his real estate venture capital firm, CC2, focused on redevelopment projects in New York City. He merged that firm into AFLG Investments and joined as Executive Vice President, where he led and co-created the real estate development arm alongside the CEO. Together, they sold a chemical company for $100 million to a Fortune 500 firm. In early 2016, Mr. Covarrubia left AFLG to start his family office and advisory firm, Covarrubia and Company. In 2016, he invested in a waste-to-energy technology that led to the eventual creation of CE. In 2017, he, alongside partners, acquired GLE Holdings, a New Zealand-based engineering firm that specializes in oil and gas refining and mining operations in Australasia. He has dedicated himself to create a more effective and efficient way to implement ESG technologies around the globe. Mr. Covarrubia is a Marine Corps combat veteran serving in Operation Iraqi Freedom. He attended Northern Kentucky University, majoring in pre-law and political science. Also joining us today is Arthur Kaplan. He is the Chief of Staff and Director of Government Relations. Mr. Kaplan attended Stanford University and graduated from The Ohio State University with concentrations in molecular genetics, French, and international business. His experiences have led him through the financial, public sales, and entrepreneurial sectors throughout the past 2 decades. He is leveraging the skills and developed relationships to aid institutional commercial property owners throughout the country to generate insights and solutions into their energy spend via his role as Chief Sales Officer at Imperium and Chief of Staff at Covarrubia Energy. The combined approach, of Imperium's proprietary predictive energy price algorithm combined with CE's renewable energy development solution provides a unique skill set that keeps clients a step ahead. Truly granular in his approach, he provides the company with its systemic and strategic expansion plans. He currently lives in New Albany, Ohio. He currently lives in New Albany, Ohio, splitting his time between family, work, and multiple charitable organizations, including being part of the Sustainability Leaders Group in Columbus, as well as on the development boards of Nationwide Children's Hospital, the Ohio State University Center for Real Estate, FIDF Ohio Chapter, and After School All-Stars. So with that, I'm going to turn this over to Arthur, and just to let everyone know that this webinar is being recorded, and I will send a link to everyone at the conclusion. So if you weren't able to join or know of someone who was not able to join us today, we will have that link available. So with that, I will turn it over to you, Arthur.
Karen, that's thank you, and that's quite an intro for both RP and I. sounds a little different when it's coming from someone else. So thank you to everyone, obviously, who's joining on this call. We figured we would briefly go over our corporate overview, which is ever changing in a positive direction in terms of expanding the number of developments and number of gigawatts we actually have currently under development. Go through that and really open up the floor to you all to make sure we're answering to a Q&A and answering relevant questions to the manufacturers on the call and partners as well. Do you guys see the corporate overview page?
Yep, we can see it.
Okay, perfect. And I will start going through this. RP, do you want to start off, since obviously this has been in creation before I officially joined the team, so I've been officially on the team a little over 2 years, and this started obviously before I joined, but
yeah, that's fine. So when Reed Sirac and I, we were sitting down and having a glass of bourbon back in 2017, essentially trying to understand how we could take renewable energy and actually make it feasible. After we had our experience with investing in the biodigester company, it was we needed predictable gases that was generated from a waste product, and it needed to be solely focused on one specific feedstock, generating the gases long term. So when we were looking at that sort of technology, that led us to pyrolysis. And our unfortunately, this is an older deck. Our new CTO, Dr. Shane Carter, he has a chemical engineering background, a PhD in chemical engineering from Waikato University on anaerobic digesters, essentially bringing everything together under the pyrolysis thought process and getting it to a scale where it's profitable, bankable, and commercialized is how we approach CE's full structure. And we can do it behind the meter or in front of the meter type processes. So the thought process that we really dove into is we needed to do as much development work upfront and take on as much of that risk in the early stages of the company, because most banks and most partners, which we have a few on here, would not be interested in taking those financial risks, not just because it's soft dollars that you're just never going to recover, but it's also some of these larger organizations just don't have a mandate to do such. So the first 2 years of the company was really just about really driving into the core ethos of what we were trying to accomplish. And that was taking the risk. And unfortunately, I had to take the brunt of that with my checkbook. But we're now at an entirely different stage where we're in the final stages of demonstration to head to commercialization. So that is where we have really focused on getting as many gigawatts underneath development that made sense. No fuss or muss about it, just absolutely getting it to a point where once we get to commercialization, we can start just executing and relieving the risk of the development costs that I think a majority of the people on this call understands from a power perspective and a gas perspective. It is not a cheap process. So that was our approach when we were building the business from day one. And we've been executing on that very, very steadily. Slowly but surely would be the terms I would use. But that's essentially what the first page goes over, and generating clean fuels for power plants, so then we can decarbonize a very hard sector to decarbonize, which is large industrial users. And so you guys can have a suite of options to come to and it be reliable, unlike wind and solar, which is nice from a theoretical standpoint, but when you actually use it, it just doesn't meet your guys' demands, which is the unfortunate nature of wind and solar. And we're learning that the hard way across the world. So
to add to RP, and just to give you guys a little bit more of an update, we're actually under development in various phases on over 10 gigawatts now, not 7 gigawatts, across 3 continents. So obviously in the United States, a few power plants in England, and a larger one in New Zealand as well. Again, the primary focus of this is really on the reliability aspect, to make sure it's truly reliable, number one, and obviously renewable, number two, which is a huge focus, for everyone's for tax benefits and so on. To go over a little bit more of our technology, it's all focused on pyrolysis. And for whoever is familiar with it, I apologize, but pyrolysis is, people automatically assume it is incineration. It's nothing to do with that. Incineration requires oxygen. Pyrolysis is a vacuum, oxygenless process. And how we do it is do it through ablative disc technology. So imagine a platform, a hollowed out screw. Ours is specifically around 20 feet long. And we put pelletized processed plastic into it, where we have an electronically heated screw, no open flame, heated at very, very high temperatures, over 800 degrees centigrade, which breaks that plastic back into its original parts, which is obviously renewable natural gas. An interesting fact, again, not sure if you're aware of, but you take a barrel of oil, around half of that actually goes to new plastic production across the world. So we need to make sure that, at least at this point, especially where everything's headed in terms of manufacturing as well as AI, we're taking that power and taking those plastic products and creating it back, cycling through the system to create baseload power. Whether it's adding it to the grid, which is one of our obviously options, and connecting it to PJM and ERCOT and other markets, as well as actually providing reliable, sustainable behind-the-meter solutions for the large manufacturers and data center providers that need the power but can't get the power because of the queue or because there's no excess capacity in their relevant markets or on the grid. I'm sure some of you on the call are aware, PJM market as an example for the queue, you're looking at, they might say it's 4 or 5 years, but realistically 6+ to get on the grid. So again, our solution is we build these custom behind the meter solutions, ranging from 10 megawatts to 1 gigawatt for our clients. And then obviously throughout that process, we can apply to get connected for the interconnect study to get connected to the grid as well. Kind of gone through this slide. Just to go over our team a little bit. RP, do you want to go through that?
Yeah, I can. So when we sat down and so Steve Davis, our late vice chairman, I brought the idea to him, and Vlad Kasputin, who is our chair of compliance. Reed and I, essentially had the idea somewhat in a very infant type stage thought process, and Steve just basically said, you got to start the company and you got to do it now, because what you're doing is going to actually do what you think it's going to do. So we launched the company. We built the board around Steve, Vlad, Dr. Matt McGuire, Reed, and John Havens. The second, we basically were the founding members of CE. And then Aaron Cohn, our COO and general counsel, who's been my corporate counsel for a better part of a decade at this current juncture, joined in as well, along with my personal CFO. She moved over to be the CFO for CE for the time being, but actually our new CFO, Jamie, is on here as well, and he'll be coming over officially in the next couple of days. So we've added some really impressive people over the years, including our 2 directors in the UK who are in the process of closing a $802 million acquisition that they're waiting for my signature today to get ready to close. So Steve McKenna and Lee Hounsen, they've helped build out an amazing division in the UK. And there's a couple other things missing is Dr. Carter, which I had mentioned already, but he'll be our director of our New Zealand operations. And we have a couple of directors down there that we're going to pull in together to help build out that arm. We have a very large joint venture that we're currently working on down there. That will essentially stabilize the New Zealand grid, because what we were dealing with here in the United States is not a unique problem to the United States. The United Kingdom and New Zealand are dealing with the exact same problem as we are. They just have more finite resources than we do. We are self-inflicting pain. They actually just don't have the natural gas availability like we do. So, when we were growing out the team, it was about finding the right partners, and you see the team within CE, but there's other team members, like our lobbyist Sean Nelson, who's also on the call, who helps bring in fantastic relationships. Our partnership with the Columbus Partnership, which I think Mark Patton is on, who has helped us tremendously grow this out. I think John and Christine is on here too from Black and Veatch, and our partners there who have helped us absolutely just catapult this to the front. And then our bankers at Goldman, John Eleuterio and Peter Perush, have done a very great job in helping us navigate through what this is going to look like in the future. And we're getting at we're at critical mass now, so that you see the CE team, but there's a broader team of consultants at Battelle, Black and Veatch, and Goldman, and our lobbyists and our partnerships that we don't put in our marketing material for obvious reasons, that have helped make this company beyond impressive.
Okay, perfect. So in terms of our current pipeline, let me explain, I guess, how we've structured this and explain a little bit about the process of pyrolysis. So as I mentioned earlier, we can take any kind of plastic, whether it's post-consumer or post-industrial, except PVC, just because of the chlorine content. We're also in the process of acquiring a plastics extruding company, which will clean and obviously pelletize our product and ship it throughout the country and internationally, obviously, for the inputs for our feedstock for our power plant. And once it goes through the pyrolysis, that, again, majority of that, we're talking closer to 90%, turns into renewable natural gas. We have two models in there. Ideally, we co-locate that next to a gas pipeline, just because we want to make sure it is pipeline quality gas. So we're able to put that on the gas pipeline, and we actually generate RTCs, so renewable thermal credits. And that's why we've actually made two separate divisions. So there's a CE Covarrubia Energy gas division. Again, this was through a Goldman Sachs structure for tax purposes, as well as a CE powered division. Then we take those gases, we pull it back into our system, into a combined cycle traditional turbine, and then create electricity, baseload power. And through that process, we generate RECs, renewable energy credits. So our end users, our clients, a lot of them obviously are buying this power via PPA in a bundled as well as unbundled and unbundled routes, meaning some of them just need the power, but some of them also want the renewable aspects in addition to obviously the RECs that are being produced, whether here in the U.S., whether it's Ohio, North, South Carolina, Oregon, Virginia, Pennsylvania, we're working on, as well as obviously internationally in the UK and New Zealand. The other main byproduct that we have are pyro oils, and that's the majority of the rest of the byproduct. And those are precursors to the plastics industry, obviously, in your oil and gas companies. And they are more than happy to and excited, obviously, to take that off our hands, and they pay a substantial amount for that as well. So we have the off-takers in place for those pyro oils and those resins, and obviously the gases. We try to generate as many gases as humanly possible to make sure we're maximizing our efficiencies, obviously maximizing the producing electricity, obviously for our clients as well as for the grid, for the properties that are that have an interconnect study and that are actually connected today. One other aspect I wanted to mention on this slide is the tipping fee. A lot of many large manufacturers are paying huge tipping fees for your landfill companies and so on to dispose of their plastics, as well as various kinds of plastic recycling companies. And so part of our value add on that side as well is our business is, again, focused on gasification, as producing as much electricity and gases as possible. So we make sure to lower that cost significantly. I can tell you one of our partners is Right Rug nationally, but they're based here, headquartered here in Columbus, Ohio, flooring and carpeting company across the Midwest and East Coast. And again, not sure if you're aware, but most plastics, you're talking, 90+% is made of plastics for your traditional carpets. And we've almost more than halved their tipping fee, because at the end of the day, all we care about is our feedstock, and we want to make sure we pass on that savings. Number one. Number two is that it's a sustainable cost for the end client. You can obviously use that. And number three, obviously, we're saving. At the end of the day, we're saving costs to them as well. They also have the priority on if they want part of the power. Obviously, we're happy to sign PPAs with them, as mentioned, bundled or unbundled with the renewable energy credits. RP, anything I missed on this slide?
No, we do have a question though. And Arthur, you got to fix your mic or something. There's a horrible background noise going on there.
I do not see the question.
It's in the chat. I'll answer it. Just fix your mic. So we had a question in the chat. So the plastic feedstock, because of how the pyrolysis unit superheats the hydrocarbons, it takes out most of the volatile and unlike molecules within the gas structure and takes them down to just RNG and hydrogen. So actually our final stage of testing for our demonstration unit is to do a gas test with the intercontinental pipeline. So once we get confirmation for them, we should be able to put our gases onto the intercontinental pipeline. We do have a partnership with our project in Oregon, so it's in Lynn County, Oregon, that essentially will, it's funded by the pipelines. A majority of the equity will be coming from them in that structure, and they've already certified the gases from that perspective. That it's just, we don't like to tout that until we have the intercontinental pipeline certifying the gases for us. But with that being said, it is different because when you're dealing with landfill gases and anaerobic digester gases, which is the other two main producers of RNG, they're not breaking down the molecules the same way as pyrolysis does. If you want to look at a more similar technology that you want to get an idea around, but it's not as clean as pyrolysis, is gasification, which the oil and gas companies have been using for several decades now. Our technology is very similar to that in how we control the breakdown of the molecules over that time period.
Does that answer the? Okay, perfect.
Yeah. Yeah.
And I apologize. That was on my end. Is that better?
Yeah. It was giving me a little bit of a headache. I'm not sure if it was giving anyone else one.
No, perfect. The other side, as I mentioned, is the power division. And again, once we pull that gas back from the pipeline. It goes into the turbine, into our combined cycle turbine system, and that's where the power division sits to create those renewable energy credits. One of the pieces that gets rid of gas price volatility is we make sure there's a fuel supply agreement between our gas division and our power division in advance. So we control that that cost to make sure we are creating baseload power and to make sure there's no issues. So if there's volatility in the outside market on gas prices, those aren't not influential, at least for us, from a stability and reliability standpoint. So in terms of, if we talk about, in terms of renewable natural gas, the one thing I have not mentioned is in terms of what it's actually producing is the RNG. It's around 80% if you split it, and we call it turquoise hydrogen. I'm sure there's a lot of shades of it in the press, but again, it's not solar or wind, so therefore we have to call it turquoise hydrogen at the end of the day. In terms of emissions, a lot of questions have come around the fact of, and again I mentioned this earlier, is in terms of incineration and a lot of pyrolysis technologies. If you look at them, and they're focused on creating more plastics. Your Alteras, your Brightmarks, your Pure Cycles of the world, and a lot of them have a completely kind of different model. It's lower temperatures, number one, but a lot of the pyrolysis technologies have an open flame. So we make sure to minimize emissions with number one, the pyrolysis, which means again there's no oxygen and it's electronically heated. It's a stainless steel screw and it's electronically heated from both sides. So there's virtually no emissions. So it's a standard, I believe, class 1 permit from the EPA. RP, do you want to go over this piece?
Yeah, you touched on technology quite a bit, so we'll make this one short and sweet. So essentially, the pyrolysis system process on the gas side is that what we've learned is that we need to be very, very particular about how we structure the feedstock, not whether or not it's 1, 3, 5 plastics. It's whether or not it is in a palatable form for pyrolysis, which led us to believe that it needs to be pelletized. It is the easiest way to ship things from point A to point B, because trying to move this much waste in waste form from point A to point B is a logistical nightmare. So pelletizing it and pre-treating the plastic for the system is a priority, and it allows us to mix the plastics as well, so then you get a more standardized look at how it enters the system. But we want it at 10 mils, so quite small pellets that are pretty, they're roughly the same size that enters the system, because when we initially did test beds on it, we were just chipping the plastics and then drying it. So it was basically plastic flakes. And when it was entering the chamber, it would start to clog up and to be quite frank, make quite a big mess. It would work, but it would not be as efficient. But in the pelletized form, it allows it to move in the chamber. So when you're thinking of the chamber in about 20 feet, we break it down into 4 quadrants. First quadrant is it's in solid state. It's a solid plastic getting ready for the heat treatment. So, and then you have the second segment where it's heat treated and it's starting to form into gases, and it's starting to break down that chemical, that molecular structure that hydrocarbons are built in, because they're very complex structures. And that second segment, you start to break it down. And in that third segment, it is finally turning into gases, and you're really cleaning out the impurities, and that gas is starting to move. And that last segment is what we had realized also in the test is that the group that we tested the technology on did not account that gas takes up volume. So we have been designing a pressurization system. So we begin that pressurization and that final stage, so the gases are meeting PSI levels, because the gases in the chamber will move around about 6 PSI, so not very fast. And with that process, that allows the chamber to have a more structured process through the dwell time, and it works a lot more efficiently with pelletized plastics. And that also sets the gases for the CCGT. So we initially had designed the process. We did not want to do the pipeline. The guys at Goldman had to really twist my arms on it until I saw the greener pastures ahead, about what that would look like, because I didn't want to become a gas company. We were strictly a power utility, but that being said, the gas division adds so substantial amount of value to the business in so many different ways. But with that being said, that the gas is then prepped for a CCGT, and the pressurization, the temperature, the molecule makeup, which is a question we answered earlier, and or the pipeline, which there's very specific criteria on how to enter certain pipelines and how to exit certain pipelines. So the chamber we essentially break down into 4 different quadrants. First, a solid feedstock, pre-treat the chemical breakdown, and then gases, and then pressurized gases is how we looked at it. And that being said, that RNG and H2 that comes from this process is it's 3 nines clarity. So we're talking as clean as gas as humanly possible. We can get the hydrogen to 4 nines, but given it's just going to be burnt, it's not going to be utilized for other processes. It's not really necessary to get that clarity out of the gas. So we're just going to stick to 99.99% clarity on these gases. So Arthur, we can move on to the next segment.
So in terms of procurement, obviously, one of the questions we get asked as well frequently is, do we have enough plastic feedstock? And I believe our main consultant, Bob Render, is on the call as well. And believe it or not, we have enough in the U.S., just in the U.S., and the percentage is around 2% of that will power all the power plants right now we have in the pipeline, which will cover 10 plus gigawatts of production on an annual basis. So the plastics piece is really not an issue, especially because of the fact that we can take, like I said, all plastics besides the ones with chlorine at this time. On the second bullet point, as I mentioned, we have 2 types of models in terms of we are acquiring actually existing power plants as well and converting it to our P2P technology. So we have old coal-fired power plants and taking obviously the turbine piece of it and then adding our pyrolysis technology to it, and creating truly a remarkable renewable asset to really speed up the process, especially if those assets already have interconnect studies done and rights.
Yeah. So we're acquiring gas turbines, not just coal fired. So we have one coal fire project that we are currently working on and converting to a P2P, but we'll have 4 different gas turbines, 2 in the US and 2 in the UK, that we'll be converting to the P2P process. The UK assets, we've got overwhelming support from the UK government on that, and they're actually working on power purchase agreements for both of those assets as we speak to convert them to this process. So it's taking old legacy assets and bringing them forward was always that it's one of the parts of the slide. So it's taking old legacy assets and giving them a reuse in life or a release in life, especially the coal fire plant, which is it's an engineering marvel, but at the end of the day, it pollutes the world around it very significantly. So it has to obviously go. But that project is an 1,800 megawatt unit. We just don't talk about it a significant amount. The partners on the call that know about it, they know why we don't talk about it. But it is a wonderful project, and what we're going to accomplish with the main equity partner in that is likely the largest data center farm on the eastern seaboard is the goal of the majority equity partner on that project. So that being said, we do look at old coal fire plants as well, and as we finish up that specific project, we'll probably take a deeper dive into looking at other coal fires and converting them to the same process and understanding how we can really integrate, because the issue with that project is that we're just tearing down all that infrastructure. And I would have liked to obviously study it and see if we could reuse some of that infrastructure, because some of these coal fire plants were so well engineered, they literally die at the end of their coal supply, or they're still capable of outliving it, but they just don't have enough coal, and coal shipping is logistics is not exactly economical in the United States. We learned that with the plastic side of everything, because our logistics network in the United States is antiquated, would be the nice way of putting it. So, with that being said, the acquisition of plants and the 1.1 gigawatts is a far short number than what we're actually accomplishing, but we like to under promise and over deliver organization. So we say we're going to do something, we're going to shoot for the moon and hit the stars type thought process. So that being said, Arthur, we can yeah, you guys see the projects there. So I didn't see that slide. So the two assets that we're acquiring here in the U.S. are Kings and MEC. Those two assets are partners at Mitsubishi. We have an OEM exclusivity with Mitsubishi products currently. They actually developed those two plants, and they are wonderfully designed plants. And we want to essentially finish up those acquisitions. Bishopsgate and Cokinsey in the UK are not the assets we're talking about. The assets we're talking about, we do not list on public forums for multiple reasons. But Bishopsgate is actually going to be a transfer station as well that links the city of Central London to a network of renewable power. We've been working with the City of London for about a year and a half now on trying to solve their energy problem. They have this very expensive tax coming that will bankrupt some people if they don't find a way to find new resources of renewable power. But the problem is the wind assets from Scottish Power is not doing what they had hoped it would do. And Cokinsey is actually an old coal fire plant that is a brownfield now that Scottish Power wants us to turn into a P2P system. So, go ahead, Arthur.
Nope. And just to, when you guys take a look in terms of how many gigawatts here, you're around 4. And as RP mentioned, we have over 10 under development. Again, these are the ones that are we can even with confidentiality publicly disclose, but we definitely have others throughout the U.S. and obviously New Zealand is not on here as well. And again, just to give you guys an update, by 2030, we're really looking at, I would say, even more than 10 gigawatts based on the partners we've brought on board. I'll mention them again. I mean, some of them obviously are on this call and they're key partners for us. We are based in Columbus, Ohio, is where our headquarters are. So Columbus Partnership obviously has been a tremendous help. We're involved with the OCTC, Ohio Chemical Technology Council as well. RP actually just recently, it'll come out on Monday, spoke at EPSA for a podcast there. And our partners obviously at Black & Veatch, as well as Battelle, which actually will, they're not unofficial R&D arm for the federal government with a lot of chemical applications, obviously, and huge in the energy sector, have been a very strong partner with us. And And that's what we've been doing. A lot of people have asked us, why we haven't announced much, and we've been quiet. We've been working on for the last 2 years in terms of really making sure we have all the right partners in place, and I think we're really almost there, right there. Part of the reason we don't have a website as well, we want to make sure when we truly already, although we've been working on this, and RP has been working on this for 5+ years, we've launched. We want to make sure when a lot of the information goes public, no one can argue with us on anything. And once we go loud, we really go. We're on full force. So,
Arthur, let's stop there and
yeah.
let's open the floor for some questions. Does anyone?
Yeah, if people have questions, they can go ahead, chime in, or you can use the raise your hand function and we can call on you. So feel free to just jump in or raise your hand. Not seeing any hands currently.
No.
I have a quick question. This is Mike Grella. There's a lot of I think trepidation in interconnecting with PJM right now, and uncertainty with the grid. And as I've had some previous conversations with Arthur, we have some concern about penciling out a PPA, not knowing how quickly PJM can move. And do you have any insight into what's going on over there? And is it it's not going to be seamless, but how difficult is that process?
I mean, with the PJM, it's pretty clear that they don't care. It's not, grid security is their main target. And this whole input, and AEP, filed a very, very straight up notice to PUCO here in Ohio about 2-3 weeks ago, basically stating, hey, if you're a data center and you're wanting access to the grid, it's better to go through the behind the meter solution, which is a nod to us. Or you need to sign a 10 to 15 year agreement, and you got to pay for it up front, because the
90%.
infrastructure, so that infrastructure from getting it from point A to point B, I mean, AEP's already spent probably 50, last I checked, it was right around $54 billion on new transmission lines, and it's still only 60% of what they're trying to accomplish. There's still another 40% of what they need to do to get from point A to point B. So the PJM and AEP are trying to solve the grid security problem, and our task is to make sure that we have that back-end solution for them. So when we do end up putting some of these behind the meter assets back onto the grid, we can do such. But AEP and PJM made it very clear that if you want to be on this grid, you need to wait or find another solution that you can justify, and you have to have the dollars to do it, or you're going to spend the money here for transmission lines, and you're still going to wait 6 years. So it's not that they don't care per se, but they're not worried about the situations around data centers and manufacturing the same way we are, because they're tasked with a much more serious problem, which is keeping the lights on in our citizens' doors. Because if we have blackouts in the Midwest, that is very, very bad for America.
Yeah, this is Mark. I just might pipe in. Mike, we talked to the folks at AEP, and they were very supportive of pursuing this, and happy to have more solutions.
Yeah, my question also related to the timing, the bureaucracy.
Yeah.
I mean, 6 to 8 years is what they're telling people, pretty confidently too.
To interconnect.
Yes.
Okay.
And they've been pretty hard and fast on that. And we're hearing that not just from them, but they've told the same stuff to our point of contact at Mitsubishi. They've told the same stuff. They said the same things. The Mark Patton Columbus Partnership. Um, they've told the same stuff to a couple of hyperscale partners that we've talked to. It's pretty straightforward, and we've been discussing with Sean Nelson, who's on this call, around an RTO split, where Ohio and Pennsylvania, who have their own authority, since one of the projects that we're working on in Pennsylvania, they developed that, but splitting an RTO would take FERC approval, and I mean, that would take 5 years. So if Ohio and Pennsylvania decide to split from PJM, which is a pretty heavily big rumor, it will take time there too. So I mean, it would take us, 18 to 24 months to get something moving, depending on size. So I'm assuming around that 150 to 300 megawatt range. But if we could do something, smaller, where we do 50, 50, 50, we can do that faster. But it really comes down to what sizing we're talking about here. So there was a question in the chat that I just answered. So.
Other questions for our panelists? Feel free to raise your hand or just jump in. Okay, not seeing any other questions. Well, if there are no more questions, just really wanted to thank RP and Arthur today for their time in presenting some of their fascinating technologies that they're working on. Again, I will have a link to this webinar available to all registrants afterwards. If you have additional questions that you did not get to answer or ask on this webinar, feel free to send those and I will forward them on to Arthur and RP. So again, thanks everyone for joining us this afternoon, and hopefully we will see you at a future event. So thank you, everyone.
Thank you for having us, Karen. Thank you.
Thank you. Goodbye.